So welcome everyone. For those of you who don't know, I'm Melissa Wu, the CEO of Seeding Labs, and thank you for joining us today. As you may have heard me say earlier, I'm so happy to have the opportunity today to connect you with one of Seeding Labs' partners, Professor Cynthia Ibeto. Professor Ibeto is the head of management of technology and innovation program at the Africa Center of Excellence for Sustainable Power and Energy Development. This is a center of excellence at the University of Nigeria in Nsukka, where she is a professor in the Department of Pure and Industrial Chemistry. All right, so that was a lot. Um, it's one thing to know someone from their CV, but another to understand who they are by their motivations. And that's what I want to share with you. Professor Ibeto is driven by a passion for improving the standard of education and research, and her eye has always been on the impact of those on sustainable development. On the research side, her through line has centered on how we as humans can manage and minimize our impact on the environment. Using her expertise in chemistry to address this, her research has spanned harnessing alternative energy from waste products to remediating soils from pollution. She's an active member of the Nigerian and global chemistry communities and has been recognized for her research excellence and dedication to the profession. Just two of many notable awards include a National Young Scientist Prize for Women in Chemical Sciences and a Gold Award of Excellence for significant contributions to the Chemical Society of Nigeria and the chemistry profession. Equally important to her personal impact on environmental solutions, if not arguably more important for her, is her impact on training the next generation that can carry forward the urgent work of environmental chemistry research in Nigeria. And she knew that one of the critical factors for success for training the next generation is having an enabling environment for the students to conduct research. It was this that led her to connecting with us at Seeding Labs. She championed her department's participation in Instrumental Access, a program that we operate to provide scientific institutions in developing countries with access to laboratory equipment and supplies. I'm honored to have Professor Ibeto here with us today to share her story of how she is working from the ground up to build capacity for waste management and water treatment. Thank you, Professor Ibeto, and all of you here with us. And please settle in for an incredible journey. All right, passing on to you, Professor.
Thank you, Melissa, for those kind words. I would say that I'm delighted to be here to share my experience from the University of Nigeria in Nsukka and speak on strengthening environmental chemistry research, building capacity for waste management and water treatment. I'll focus on the need for equipment within our university and the national community. I'll look at our attraction to the Seeding Labs Instrumental Access Program and some challenges we face participating in it, the intended use of the equipment that we requested for and obtained, and major impact so far. I'll give a brief overview of research in waste management and water treatment. I'll highlight progress in water treatment research and of course mention areas for support. Growing up in Lagos, which is one of the most populated cities in Africa, one thing that was very glaring is the waste management issues. And of course, over the years, we've seen how this has affected environmental pollution and necessitated the urgent need for pollution control. With these in mind, over the years, I had the zeal to focus on waste management and pollution control, and that led me to specializing as an environmental chemist, because environmental chemistry plays a critical role in addressing both issues. First of all, it provides scientific basis for pollution control. As an environmental chemist, I apply the greater part of my early career into assessing human and environmental risk associated with pollution control to provide a basis for pollution control and, of course, waste management. This field enables development of green technologies because it explores and evaluates the impact of these technologies as it addresses pertinent issues relating with environmental studies. Of course, environmental chemistry links laboratory research to community impact. In fact, the basic environmental chemistry research cannot end up in a journal just there. I mean, it's something that can be cascaded down to the community, and it has practical applications, and it also helps to improve, the developmental needs of society. So take, for instance, one of the typical things we do in my university is analyzing wastewater surfaces. And we have found how critical this is in addressing certain environmental issues in the community just by enlightening rural dwellers of the need to treat properly the water they consume, and actually to give them pointers to how detrimental the polluted water could be to not just their environment, but also to their health. And very importantly, environmental chemistry also supports evidence-based policy, not just theory, really evidence-based. Going to the equipment needs of my department, I will start by saying chemistry is a central science and very related to a good number of science-related courses. So we have chemical engineering, you have medicinal chemistry, have pharmaceutical chemistry, agrochemistry, and a long list. So in the Department of Chemistry, we have a lot of students offering our courses. And with that, there is really no time we feel that these facilities or equipment are sufficient, because we want to really give the best to the students and make them, very good with the practical skills that is being passed on to them. To put this in perspective, first year students that take, I'm not talking about theory courses, but practical courses are over 7,000. So you can imagine the need to have as many facilities as possible to help the students practice over time the chemistry skills and knowledge we're trying to impact on them. Academic staff, on an average, 35 on ground in the university at any point in time. Postgraduate students vary. That could vary from 30 to 40 or 50, depending on the admission within the year. But I wanted to spotlight the final year students for the chemistry in the university. We have on an average 60 students in final year. And this means there is a need for adequate facilities and resources for their research projects. I find this very important because the foundation is important for these level of students. Because if the foundation is weak, we're looking at what would they build on when they become postgraduate students. So we are very intentional in trying to make sure that they are well-grounded in chemistry skills, in practical skills, to help them to be able to further their education as graduate students or as researchers in the future. Our equipment needs also transverses just research and teaching in the university. As the first indigenous university in the country, we attract a lot of not just students, but also researchers. And as an academic in a university, one of the things that drives my work is the whole idea of fostering as much as possible interinstitutional, interregional, and of course, international collaborations. And there has to be an enabling environment to be able to do this. So it's very key that we try as much as possible to equip our labs, be well grounded in these areas to be able to give to others, especially neighboring universities and other universities around. To put this in perspective, I would say we have in Nigeria 307 universities. And in the region where I stay, the Southeast region, we have about 70. So you can imagine the number of students and researchers we attract to the university. And very important is the enhancement of community impact. We're not just talking about a rural community, but even starting from the university community to be able to use what we do, the research and teaching, to impact on them. With these needs, you can imagine my delight when I received an email informing me about the Seeding Labs program and mentioning that I have been granted a waiver to be part of this program. To join or benefit from this program, you have to pay a program fee. And as a Schlumberger Faculty for the Future Fellow, I was informed that the Schlumberger Foundation was going to pay that program fee and I could take part in this program. So I was so delighted because this is what I was been looking for, a way of helping my department to improve on the facilities on ground so that the students can be well-grounded in the skills they're acquiring. So the first thing I did was to go to the website, Seeding Labs website, and I saw the number of universities that had keyed into this program, over 100. And of course, the number of undergraduate students, over 200,000, benefiting from this, I must say, very impactful initiative. And of course, my response was very quick in saying that I definitely will be part of this program. And I quickly delved into applying, and I would say that I received a lot of support from the staff of Seeding Labs to be able to pull through that application. Of course, there were a couple of challenges. I mean, the main challenge, when we go to the website of Seeding Labs, you're informed that it's going to be a rigorous process, a good number of amount of time. That amount of time has to be invested into the application, into selection of the equipment, into processing the delivery of the equipment. But for me, nothing good comes easy. I didn't mind at all that a chunk of my time was going into this process. But what became a bit difficult was receiving the consignment when it got to the port of entry. And I understand that this is peculiar to my country, which is Nigeria, because other countries won't have this problem. Even when you receive a grant, you have to pay for every item that has come in, even though it's a grant. So getting an agent to clear the consignment and all that, and actually pay the clearance fee, the clearing fee for receiving that item into the country. So that was the main hurdle. And it took a bit of time to overcome those challenges, but eventually we were able to receive the consignment. Within the same year, I applied for this program in 2023. And later that year, after a couple of months of being able to sort out the administrative issues with respect to receiving the consignment, we received a 2-feet container containing the equipment. And so you have on the left the big equipment, the ovens, the coolers, the dryers, and then we have all the facilities that were inside the box, mainly apparatuses, glasswares, heaters, refractometers, water baths, a good number of equipment that were quite relevant. I would say that when the consignment arrived at university, I just told myself it was worth the effort. So yes, the equipment was intended for both students and staff, research. And top of my list was to make sure that the practical sessions of students were well prepared. They had a lot of facilities, enough to go around for practice and the real experiment themselves. So which is what we achieved with that consignment. And we're obviously making good use of those facilities. And it's impressive to note that even though this consignment was received by chemistry department, a good number of other departments in our faculty are benefiting from it. I understand that geology departments are using our facilities for field trips, which is very good. It's a welcome collaboration, as they also have a good number of facilities that we now use. Staff of our department have also been using the equipment for their research. And I can highlight 3 major areas that this equipment has been very useful for. Synthesis of materials, for instance, nanomaterials, support for water treatment studies, particularly suction studies, and in production of biofuels such as biogas, biodiesel, bioethanol, and also biolubricant. These have been very relevant in the past 2 years for this particular project at undergraduate level and also postgraduate level. And in the staff who prepare their samples for research and other studies, especially exchange programs, where they have to prepare their samples before taking them out for analysis, have also found their facilities useful. I would say that over the years, because of my focus on waste management and pollution control, I have looked at biofuels, biogas, biodiesel, bioethanol, optimization of the production processes, focused a bit on biofertilizers that are good soil amendments and also briquettes for alternative heating materials and cooking materials. So I would narrow down to what is more currently being done in my department, which is bioremediation studies of not just polluted soil, but also water. And I would say that a good amount of the research in my department is centered on this, directly or indirectly. The inorganic chemists, the organic chemists synthesize good materials that are applied in this area of study. And this has been very important because of the scope of problem that we have when it comes to waste management. To put it in perspective, globally, we have about 2 billion metric tons of municipal solid waste that are generated each year. This is a lot, and it's projected to increase by 2050 to almost 4 billion tons. If we're looking at waste management now, on the spotlight are plastic waste. So for plastic waste generation globally, we have about 360 metric tons. Next to plastic waste, I must say that food waste is also key, especially when we're looking at waste to wealth. And that is to the tune of 1.05 billion tons. I'm talking about data of early this year, this March 2025. So with these waste generated in very large volumes, there are a good number of challenges that have come with it that have also hindered proper collection and disposal. There are, just to list a few, inadequate infrastructure due to insufficient funding and investment. We also have limited public-private partnership, and of course, ineffective regulatory frameworks, especially for enforcement. And with that, side effects or other consequential effects are environmental and health impacts. To narrow down to the problem in Nigeria, this is data from 2024, about 30% of the waste generated are not efficiently collected for disposal or reuse. So this is an ongoing problem and a lot of researchers are currently working on addressing these issues with a good number of initiatives. So globally, a good number of techniques are being applied to managing waste. So composting, bioremediation, valorization of plastic waste, transforming plastic waste into useful products, pyrolysis, a cleaner way of burning, of incineration, recycling technologies, and of course, circular economy approaches. Again, tailored towards waste to wealth or redirecting the reuse, reduction, or the recycling of these waste materials. The energy sector is very critical and crucial when it comes to waste management. And I can say that biomass or bio-waste transformation has been applied in various ways in the energy sector. And these applications have been quite useful over time. So apart from the thermal processes where heat and power is generated, you also have the biochemical transformation, technologies like anaerobic digestion, fermentation, pyrolysis that yield useful products like methane, compost, and also bioethanol. So we're greener ways of addressing issues of transformation of waste rather than just the classical thermal methods. To be able to explore viable options for transforming waste to useful products, I have carried out research visits that address this targets. And one of my research visits was in being able to generate digestates that are suitable biofertilizers, but also can be used for bioremediation, especially for cleanup of oil polluted soil. And it all starts with waste material, whether food waste, uh, whether paper waste, whether animal waste. So there are a good range of waste materials that can be applied to biofertilizers or soil amendments and also used for cleanup of polluted soil. And it's very impressive the impact of these waste materials, especially when used as soil amendments. That's one study that I carried out in Lancaster University, and this progressively gave a good yield and very amenable properties of the plant material. There are other initiatives with respect to cleaning up the environment, especially with respect to plastics. And this dates back to over a decade. I mean, addressing plastic waste issues is not just a thing of yesterday or a few years ago. It dates back to 2011. And in Nigeria and Kaduna State, there was an initiative to use plastic waste to build, to have buildings. And looking at the progress in having this building, at the end of this building, 8,000 plastic waste bottles were used. And this is just one building. So you can imagine the amount of waste bottles that can be recycled with this initiative. If projected, this is just one building. And also in India, in Sahor, 2020, that was about 5 years ago, there was also the initiative of using plastics for road construction. In this case, pulverized plastics mixed with bitumen, and then, have that asphalt mix and then used for road construction. And studies were carried out to see how, durable the roads were. And over time, it was certified, quite comparable to other conventional materials that are used for road construction. Over the years, the initiative of using plastic for other studies, especially for building and construction, has progressed to, for instance, pulverizing the plastic or having initiatives of partial replacement of plastic of cement or sand with plastic in concrete production. So a lot of initiatives are tailored towards that for building and construction. Waste management issues are critical because it does not just have environmental effects, it's very crucial to health problems. And water pollution is one of those consequences of not managing waste properly. With rising industrialization and municipal waste generation, there's a huge possibility of having many water sources polluted if waste is not collected properly and disposed adequately. A good number of areas have limited water supply, and you can imagine that that problem will be compounded if available water sources are polluted, and so scarcity issues will be, aggravated. And so it's crucial that waste management is handled to circumvent these problems. Local treatment technologies for cleaning up polluted water are limited, and in fact, there are also limited options to applying these technologies and effectively utilizing them for water treatment. So it is very crucial that waste management is addressed and addressed as often as possible. So just to give an idea of the typical contaminants that can be available in water, different sources of water. And over the years, what has been studied and found in water as a result of the presence of various industries in society. So we have metals like lead, cadmium, nickel, manganese, chromium. These are metals that can have detrimental effects to health. And we have dyes, methylene blue, dyes from textile industries. We have phenolic compounds also. We have polyaromatic hydrocarbons. These are pollutants or contaminants that could arise from oil spills. We have pesticides from agricultural activities. We have chlorinated hydrocarbons from, for instance, transformer oils, the typical PCBs. This can also get into the environment. And very recently, I would say very recently, we've had pollution from pharmaceuticals, antibiotics, and also personal care products. These are common contaminants that have been studied over time and found to be at significant levels within various water sources. What are the options for treating water? In many rural settings, I'll start with Nigeria, the typical method for the local women to treat water is coagulation. So you have alum put in water within a clay pot or a container, and then it agglomerates, the solid residues, and then we filter, simple decantation or segmentless filtration. You have the clean water obtained to a certain extent for consumption. So this is one of the local treatment methods. But over time, with a good number of industries and the waste generated from these industries, there have been more viable methods of treating water. So from adsorption to membrane filtration using semi-permeable membrane, to phytoremediation using hyperaccumulators, plants that are hyperaccumulators, to microbial degradation using fungi, for instance, and also sonolysis, application of ultrasound to break down contaminants. These are a range of water treatment methods that have been applied and largely studied by a good number of scientists, including Nigeria. But out of all these range of water treatment methods, one that is preferred is adsorption. This is because of its low energy consumption, high efficiency, reusability, its simplicity, and of course, versatility in addressing a range of water contaminants. And so most of the water treatment studies we've carried out at the university have actually been centered on sorption studies. And a good number of researchers have come up with viable and efficient solvents for removing these pollutants from the environment. And of course, this also cuts across global researchers that have also addressed this with very good and efficient solvents. So I'll start with nanoparticles, which are materials up to 1 to 100, and like having unique physical and chemical properties due to their high surface area to volume ratio. So the high surface area is one attractive property of these materials that helps to absorb these pollutants and adsorb them to the surface of these materials. So very common is titanium dioxide, but a good other nanoparticles that have been produced, so zinc oxide, manganese oxide, and the likes. Progressing from that are carbon-based nanomaterials, also having very unique properties such as high surface area. But in addition to that is mechanical strength, which is an added advantage for these materials because one of the attractions to a good number of the solvents that are developed is the reusability of those materials, because environmental scientists are quite focused on not adding more problems into the environment as a result of addressing one. So reusing solvent materials are critical so as not to easily discharge these materials with every single use. So there are a good number of the carbon-based nanomaterials that have been produced, especially carbon nanotubes. Nanocomposites also are another group of solvents that have been effective in removal of contaminants from materials, including water. And yeah, these are solid materials such as composites, a mix of nanomaterials onto standard materials. So examples are coconut shell and bone, graphene, enhanced plastics. So the idea is a good number of research is being carried out on utilizing waste materials to produce these nanocomposites, and at the same time trying to make them as efficient as possible in removal of these contaminants. Very, very recently, well, even though a lot of studies have been carried out, but there's a lot of progress made into production of the synthesis of the metal organic frameworks. And of all the range of solvents that I've listed, this seems to be one of the group of efficient solvents for achieving almost 100% removal of contaminants from the environment. So a range of these metal organic frameworks have been produced and synthesized, and there is renewed interest in making sure that production is, cleaner, production is more efficient, and the material itself um, is able to remove as much as possible as expected, near 100% of the amount of pollutants within the matrix. So looking at future directions with respect to water treatment, integrated hybrid systems, this is not particularly new, but the idea is to be able to combine methods that can effectively near remove all of the contaminants from the matrix, in this case, water. And then a lot of focus have been going into artificial intelligence and Internet of Things and addressing water treatment issues. For instance, artificial intelligence can optimize chemical dosing, predict system failures, and of course, reduce operational costs. And a lot of attention is going in that direction. Internet of Things also, the sensors have provided real-time data monitoring and can be enhanced for compliance and system efficiency with minimal human intervention. Again, a good amount of focus is geared towards digital twinning. This is basically maintaining a virtual real-time replica of a physical object and at the same time processing that using IoT, AI, or data analytics. And the idea is more or less studies centered around simulation can be done seamlessly to be able to improve on such processes or systems. So even with the expertise we have in the field, with indigenous materials that we have, with available researchers for collaboration, there are limited national and institutional grants. Yeah, limited national and institutional grants. But these have been a good support system to be able to drive the initiative of waste management and water treatment within the country. So what do we need? We need adequate laboratory equipment, state-of-the-art equipment, modern equipment to be able to ensure that we are able to replicate the studies to more sensitive levels and seamlessly with more precision. And yeah, really the target is to have more modern equipment for this kind of studies. And so funding is required. And I think more importantly, collaborations collaborations between the global north and global south to be able to synthesize ideas and make real good progress in research. And then, of course, I'm not going to downplay the impact of access to training opportunities, which is critical, not just for the researchers, but also the technologies that man the equipment that we use for these kind of studies. And then very crucial, our university industry policy linkages. When we're talking about impact of the research we do, this is central. So, a call to action. We can all agree that there is a need to build capacity, especially with modern equipment that can be overemphasized. And we need to collectively invest in this, both researchers, both technologies, the investors, the government, everyone, stakeholders should collectively commit to environmental research because it affects all of us. We're inspired with the progress that has been made thus far with waste management and water treatment technologies. And so we're encouraged to commit to this course because if we all do so, then we can sustain the progress that is being made. And of course, the efforts will lead to the required environmental sustainability and a better world for all of us. Thank you. Thank
Right.
you. Was I heard?
Yes, thank you, Professor Ibeto. That was incredible, and it was such an honor for me to hear about your work and what you're doing. And I'm left incredibly inspired by you. Um, I Yeah, this is just it's just incredible. Um, and I mean, particularly one of the things that really hit me during your talk was how you and your colleagues have such a holistic view for how your science and efforts at Nsukka are making a difference for Nigeria. And I appreciate you giving our audience an inside look of what instrumental access looks like from the view of our university partners. I think that's pretty rare. Um, so thank you for doing that. Uh, we do have time for Q&A. But before I open up the Q&A, I do want to make an ask of the audience. You've heard how our instrumental access program enabled the final year, or is enabling the final year undergraduate students at Nsukka to really dive into their research work and investigations in environmental chemistry. Professor Ibeto mentioned that it was possible for her department to participate in the program due to financial support from the Schlumberger Foundation, a foundation which we have enjoyed a long time partnership with. There are so many visionary scientists at supportive institutions like Professor Ibeto and the University of Nigeria and Nsukka who cannot participate in the instrumental access program due to either limits on Seating Labs capacity or limitations on the universities to share a portion of the costs of the shipment. Your philanthropic donations make it possible for Seating Labs to subsidize the cost to partner institutions and also make it possible for Seating Labs to bring the next institutions into our program. Thank you. Thank you. Thank you. I see so many of our longtime supporters who've joined us today, and thank you for your support, which makes it possible for us to do this work. Um, what I ask of you is please share our work with one friend or colleague, or maybe two, or maybe 10. Um, it's especially important for us in these particularly difficult times to raise awareness of seeding labs and to grow our pool of support. And if any of you listening would like to talk to us about ways that you can help seeding labs lower the barriers of access to resources for science in developing countries, please don't hesitate to contact me. I'll have our staff put my email address in the chat. For those of you who are listening to the recording of this webinar, you can go to our website, www.seedinglabs.org, and go to contact us to get in contact with any of our staff members. Okay. All right. Now, I'd like to pass the mic now to our audience. Um, but maybe I will start off. Um, actually, no, I won't. I'd like to invite, let's see if I can invite, I see Lena Thomas at My Green Lab has a question, and I'd like to invite you to answer. Let's see if we can make that. Let's see if we can make that work. David, I think I might need a little bit of help from you to enable Lena to talk.
Hello, can you hear me already?
Yes.
Yes, wonderful. So warm regards from Germany. As you see, I'm working with my green lab, and I can share a biochemistry background myself. But when I was in university, this whole topic of sustainability wasn't there with the professors. They were not trained. We did not receive any training. And thus I was wondering whether this is something that you see as well, whether you would like to see more tools, whether your students would like to take training, or whether that's just a problem in my region and maybe you're far ahead.
Cynthia, were you able to hear that?
It was a bit, I didn't really quite get that. If you can please repeat,
Yes.
please repeat.
So I was asking, do you have enough like materials and trainings available for the students, or is this something that you encounter that also I encountered while I was studying biochemistry?
Yes, like I started from the aspect of not having enough materials, which is the driving force for embraces this initiative of seeding labs, because we had not limited materials, but a lot of students attracted to the university and yeah, insufficient materials. So we have that problem of not having enough materials. But what we try to do is to reach out as much as possible and make sure we're able to still group the students in such a way that the materials we have can be sufficient for the sessions we've mapped out for them. So yes, that's still a problem for us, but we've gradually progressed from that over time with the consignment we receive from Sydney Labs. That's a significant progress, but the problem has not been solved. It's still there, but we're making significant progress in trying to ensure that we have enough materials to go around for the sessions. We're intentional in being able to address that.
If I could ask a follow-up to that question, I'm wondering, in terms of the curricular uh, development, textbooks, case studies, those kinds of things. Do you find there's adequate resources for the teaching of the concepts and for environmental chemistry, or is it too new of a field that they're that is still focused on more traditional, I'm not a chemist, so more traditional applied chemistry topics.
The world is a global village, and it's information is almost like a click away. So yes, we have textbooks available for the students, and we rely a lot on online sources, online resources, and these online resources are made available as much as possible. One of the things we try to do in universities is to subscribe to some journals, and that subscription is made available to students too, and most importantly to lecturers to improve on their teaching and teaching content. So that's the progress we've made. I would say because of the digital age that has, I'm comparing, I started lecturing in 2008. I mean, the progress has been quite significant over the years. This would have been, I would categorize as a major problem in maybe it's early 2000s, but now with access to the internet, it's not such a problem. But we have limited availability of textbooks, materials, hard materials. That's the textbooks and tangible physical materials. But there's a lot of available information, online resources that we are using for our teaching.
Thank you. I see there's another question that's very relevant as a follow-up to this topic coming from Ken Herman. Ken, I think we're gonna open it up, so take it away.
Oh, okay.
Oh,
Wondering
Ken,
about.
Ken, are you able
Yeah,
to? We're not
yeah,
hearing you if you
sorry.
are speaking. Oh, there we go.
I'm Melissa. Sorry, all of a sudden my headset went like dead after
Of
something
course,
happened
that's
on the screen.
exactly
It's
when
great
when
to
it happens.
yes, I know. Great to see you. Thanks, it's been ages. And and thank you, Cynthia, for a really inspiring presentation. Yeah, I had some of the questions I had that sort of came up is during it, I think addressed a little bit in your presentation, but I was asking on the Q&A about consumables. I think that what the question prior was kind of getting at that. The equipment is one thing, but the consumables are really what sort of drives. And then it occurred to me, I was wondering, perhaps you can say something about the viability of chemistry as a professional career option for people in Nigeria. Is it a struggle to find students that are prepared to be that committed? And is there an industrial pathway to careers in this field in the country. So it's kind of a question, almost a little bit for you, Melissa, about consumables. And when, once we get the equipment there, it's like they need to be able to use it. And I know students, I know from my days in high school and in college about chemistry, we use a lot of stuff, maybe not efficiently, but that's the nature of learning. So there's that about that. So consumables, and then about career and industrial support for, industry support for what you're doing, Cynthia.
So I'll answer. Oh,
Okay, no, please go ahead.
I'll just take a quick answer for the consumables. Seating Labs does include what we call non-perishable consumables, which are things like plasticware, glassware, paper-based products, but nothing that is a reagent, which does make it difficult for chemistry, well, and biology. Everything you need, solvents, you need you need all of that. I will say that we have partnered with some um, manufacturers who we've run in the past, time limited special programs for access to reagents. One of them was Adgene. We had a program where they were granting plasmids. And so, as you said, Ken, this is highly needed. Unfortunately, at Seating Labs, we don't have the capacity to move those kinds of things ourselves, especially considering we're working in so many different countries. But we are always happy to hear from manufacturers who do make these reagents and are looking for support in finding good places to donate those to make an impact. All right, Professor. Uh, your turn on the other side of the question, the professional side.
Okay. On the professional side, I would say I think it's a general problem that uh, the young ones would have at the back of their minds is either medicine or nothing, or pharmacy or nothing. We still have that as a problem now here. They want to study medicine, they want to study pharmacy, they want to study professional courses and engineering. But what I've realized that many of the good students that come in as chemistry students, as they progress over the years, they realize the relevance of chemistry. So we're intentional in helping them to see career paths, career prospects when they delve into chemistry fields. I would say initially there's that problem of making that choice, but eventually some of them make the choice. And then when they make the choice, I was spotlighting the fact that we have about 60 final year students in chemistry department. That's a considerable number for a department, I think. So whilst that problem is still there, the good thing is by the time they realize how relevant chemistry is, we have the slogan that we put everywhere. We say it all the time. What on earth is not chemistry? Because one of the things they are ignorant about is how they can actually apply chemistry and thrive with chemistry. And so yes, it's a problem we're aware of, and we're trying to address that with sessions, career talks, and all that. On the like an industrial path, like I said, chemistry is a central science. It's quite versatile. If one who has studied chemistry and is aware of the prospects within that field would find him or herself being able to align in various industries within the country. I know that there are limited opportunities for a chemist in various industries. Not many industries are there for the number of graduates that we have coming out as chemists over the years. So maybe that's the downside of it. So if I would say with career talks, chemists are being directed to be able to use their skills, knowledge, and that profession in such a way that it would advance not just them but society. So yes, I think basically that's my own view on it.
I've got a two-part follow-up to that. And I'm wondering in terms of the equipment, that, having adequate access to laboratory equipment, does that support the students being more prepared for these careers? And then part two, standing on the other side of it, if you had, you know, access to all the decision makers of the world and unlimited funding, what would your opinion be of, like, what do we need to do as a society, as government, as scientists, as all the different things that we may represent, um, to grow the industry in Nigeria?
If I start with the first one, definitely the availability of the equipment is crucial, is critical in helping the students, in the field of chemistry. I would say that this is a very practical course. Nobody wants to hear theory all the time. So the availability of the equipment and facilities are crucial, are critical, for them to appreciate the course and for them to even want to further with it. So it's key. It's key. With all the facilities, with all the supports to advance this field, I mean, basically, I really think what we need to embrace is the right ideas, the right focus in addressing the issues. I'm just trying to narrow down to waste management and water treatment to prioritize properly, to channel funds properly, and of course, back to what I said before, we need modern equipment modern equipment. And then very importantly is policies that help to address these issues, even though we have research outputs, research ideas, and there are proposals on how to address these issues. The right policies are critical in ensuring that all the research done, all the outputs are, channeled accordingly for, national advancement.
Thank you. I think we have time for just one last question. So I want to bring on um, Polofirio. I hope I pronounced your name correctly. Could you come on and ask your question?
Hello, good evening from Uganda to everyone. Am I heard?
Yes, yes. Perfectly well.
Oh, thank you. Thank you so much. Like earlier, I had asked from the chat. I was looking at. I wanted to know from seeding lab section if, in case, if we applied and got some of these equipment from them. Yes, that one is one chapter covered. But now, is there any other? Any other promise or hope that we can have more support from them when time has come and maybe we need more? Are we going to be considered as new applicants in that area, or there's a way they do it and then maybe we get support from them? That was my question. Thank you so much.
Yeah, thank you. So I will say a couple things about one, just starting with the relationship that we build and how we do our work. And I use the word relationship because I really think that in the instrumental access program, we're not just creating access to resources, but we are building long-term relationships with the universities, with the scientists, with the faculty members and educators. And so um, we do as much as we can stay connected with our previous participants, to understand what is happening with the equipment, what is happening with their work, did it help them reach their goals, and to your point, what are the next set of needs? Um, I will say one of the things that has been amazing to see in our conversations with our previous grantees, we have seen that not only has equipment supported the educational experience and the research capacity of institutions, but it's also increased their sustainability. And one of the ways it's done that is we've heard over and over, because of the equipment, the universities are actually able to bring in more resources. Looking at just a subset of the universities that we've worked with, I think something like around 65, they've reported that after receiving the equipment, they've been able to bring in an additional $17 million worth of grants. And that could be coming from the university itself, the national government, other international governments, or other NGOs and foundations. So one, I think that is the hope, and we've seen it happen many times that with these resources, the institutions are able to bring in more and are better able to move to their next phases of capacity. Now, more directly to your question of, what about our previous partners who have reached a next stage of capacity? We do encourage you to, connect with us, tell us about it. In some cases, we may recommend that you apply again to us. Explain what has happened in the past and why there is a new need. Whether it may be you're trying to start up a new technical area, support a new degree granting program, whatever the case may be. Um, or we may recommend, other kinds of support with us being able to leverage our many connections across the industry. I think we've worked with almost or over 200 corporations who contribute various kinds of resources to seeding labs. All right. Thank you very much for all of you for joining. We've reached just the hour, so I want to, first of all, thank you again, Professor Ibeto, for sharing your work, giving us insight into what it's like to be a researcher and to be building up capacity in Nigeria. And thank you to all of you who've joined us for listening in and for being part of the larger scientific global community and sharing your support across it. Thank you.